Here's the first example of an integral where it's appropriate to do a trig substitution. So it's the square root of 25 minus x squared. And in this case, this integrand contains something of this form, a squared minus u squared, where this time here a is equal to 5 and u is equal to x. All right, so that's why it's appropriate to do a trig substitution over here. So we're going to do that. We're going to do the recommended substitution, which is u equal to a sine theta. So that would be, in this case, 5 sine theta. Oh, sorry, x is equal to u. So instead of u over here, I might as well go with x. X is equal to 5 sine theta. If I had something like 4x squared here, then u would be equal to 2x, and I'd put a 2x right here. All right, so here's our example, and we're going to need to substitute for dx as well, differentiating sine theta. Dx is 5 cos theta. So we substitute directly. Here we have 25 minus x squared, that's 25 sine squared theta. And for dx, we put 5 cos theta. Okay, let's just factor out the 25 here. So here we have 25, 1 minus sine squared theta. Let's see, 5 cos theta d theta. And of course, we'll replace 1 minus sine squared theta with cos squared theta. That was the whole purpose in doing this trig substitution, so we can get to that point. All right, so we have, underneath the square root, we have 25 cos squared theta. Let's take the square root right now, so we have 5 sine theta, 5 cos theta times 5 cos theta. All right, so let's just pull out 5 times 5. So we have 25 in front, 25, and here we have cosine squared theta. Okay, so here's where another trig substitution comes in, and let's just write this on the side. How do we integrate cos squared theta? We integrate cos squared theta using what's called the half angle substitution. So that goes like this: cos squared theta is equal to 1/2 1 plus cos 2 theta. So that's the substitution that the trig identity we use to integrate cos squared. And sine squared has a similar identity. I might as well put it down here for you. Sine squared theta is equal to 1/2 1 minus cos 2 theta. All right, this is called the half angle identity because on the left, theta is 1/2 of 2 theta on the right. All right, let's do that substitution now. All right, so here we go. 25. We'll pull the 1/2 out in front. And here we have 1 plus 1 plus cos 2 theta. All right, so we're ready to integrate. The integral of 1 is theta. And what's the integral of cos 2 theta? Well, the derivative of sine 2 theta is 2 cos 2 theta. All right, so it's going to be sine 2 theta with a 1/2 in front because that we don't have that 2 over here. Okay, sorry. I said sine 2 theta and I wrote cos 2 theta. Let me just erase this. Okay. 1/2, let me rewrite this, 1/2 sine 2 theta. Okay. All right, so that's the integral in terms of theta, but we really have to rewrite in terms of x. We were integrating, our original integral is in terms of x. So we have to substitute back. So how are we going to do that? Well, this is what we're going to do. We're going to look at our original substitution right here. X is equal to 5 sine theta. All right. Or x over 5 is equal to sine theta. So let's write that here. All right, let's look at that. We had our original substitution was x equal 5 sine theta, or x over 5 is equal to sine theta. Okay, well, here we have sine 2 theta. Well, use another trig identity. Sine 2 theta is equal to, let me write it here, sine 2 theta is 2 sine theta cos theta. All right, so let's rewrite this. So here we have 25 over 2 theta plus 2 times a half is 1. So I'll just write sine theta cos theta. Now sine theta is equal to x over 5. So we're going to put x over 5 here. But what about cosine theta? Well, in order to see what cosine theta is, some expression of cosine theta in terms of x, we're going to use this this little equation over here, x over 5 equals sine theta. And what we'll do is we'll draw a triangle containing angle theta. And we'll draw angle theta. What we know about angle theta is it has sine x over 5. That's opposite over hypotenuse. All right, so that means I'll label this opposite side x, and I'll label this hypotenuse 5. And using the Pythagorean theorem, x squared plus this side squared is equal to 25. So this remaining side I'll label according to the Pythagorean theorem is 25 minus x squared. So using this little triangle now, we can get an expression for cosine theta, which we need here. Cosine is adjacent over hypotenuse. All right, so cosine theta is equal to the square root of 25 minus x squared over 5. And now we're ready to complete this this substituting back. Well, almost ready. We need theta. We'll look at theta in a second, but here we're going to put x over 5. Here we're going to put this expression for cos theta. Okay, now what about theta? Well, again, from this equation, we can solve for theta. If x over 5 is equal to sine theta, that means that theta is the arc sine, or inverse sine, or arc sine, of x over 5. So now we're ready to put, for theta we put arc sine x over 5. And for sine theta we put x over 5. And for cosine theta we have the square root 25 minus x squared divided by 5 plus c. Okay, now using this result, let's go back to the original integral. And here's what we have. The original integral is the integral of the square root of 25 minus x squared. Now, what is this expression? Well, y equal to the square root of 25 minus x squared is the top half of a circle of radius 5. X squared plus y squared is equal to 25. Circle, radius 5, centered at 0, 0. So if we put these limits on our integral, then what we're getting is the area of the top half of that circle. So let me just draw a picture here. It's not a very good circle, but it'll do for now. So this is the top half of the circle. X squared plus y squared is equal to 25. Well, this area, according to the formula for area, the area of a circle is pi r squared. So the area of this circle should be pi times 5 squared, or 25 pi. And so this integral, since it's only the top half, should be equal to 25 pi over 2. So let's evaluate it. All right, we know we have that this integral is equal to this expression here. All right, let's just multiply through, and with the 25 over 2, we have 25 over 2 arc sine x over 5. And then here multiply 25 over 2 times x over 5, and we get actually x over 2 square root 25 minus x squared over 5. And we're going to evaluate this between minus 5 and 5. Notice when we substitute either minus 5 or 5 into this expression, we get 0. So we're just going to substitute into this first term. Okay, so let's do that. First 5, then minus 5, and we end up with 25 over 2 arc sine 1 minus 25 over 2 arc sine minus 1. The angle whose sine is 1 is pi over 2, so this is pi over 2. And the angle whose sine is minus 1, that's minus pi over 2. All right, so here we get 25 over 2 pi over 2 plus 25 over 2 pi over 2, and that's equal to 25 pi over 2, which is what we expected for the area of half of this circle.